Implants. Published by WordPress.com. Plates. Strip of metal attached to bone by screws through holes. 1. Functions of plates. Holding fragments together. Keeps fracture fragments well aligned throughout the healing process. Transmitting forces. Bypass a fracture by transmitting forces from one point to another. Working distance. Defined as the length between the two screws closest to the fracture on each side. Effect on stiffness. Decreasing the working distance increases the stiffness of the fixation construct. Bending rigidity. Proportional to the plate thickness raised to the third power. 2. Plate biomechanics and applications. Compression plate. Produces compression at the fracture site for absolute stability, e.g., simple transverse radius fracture. Tension band plate. Converts tensile forces on the tension side into compressive forces on the opposite cortex, e.g., femoral shaft fracture. Neutralization plate. Neutralizes, protect, bending and rotational forces to protect lag screw fixation, e.g., simple oblique radial fracture. Buttress plate. Resists axial load by applying force perpendicular to potential deformity, e.g., lateral tibial plateau fracture. Bridging plate. Provides relative stability by fixing the main fragments while leaving the fracture site undisturbed, e.g., multifragmentary humerus fracture. 3. Types of plates. Standard, conventional, plates. Dynamic compression plates, DCP, broad, narrow, small. Reconstruction plates, 3.5 mm, 4.5 mm. 1/3 tubular plates. Special plates, e.g., anatomical. Lock plates. Fixed angle fixation device with threaded screw heads for toggle stability. Combi holes for both locking and conventional screws. LC. Low contact, lesser compression on periosteel circulation. LIS. LIS invasive stabilization system, percutaneous fixation. 4. Lock plates. Advantages and features. Advantages over conventional plates. Do not rely on bone implant friction, instead, depend on screw plate interface. Angular stability and better pull-out strength. Prevent loosening due to axial loading as screws resist shear forces. Preserve periosteel blood supply by eliminating the need for anatomical contouring. Act as internal-external fixators, due to improved rigidity. Features of locking screws. Provide axial and angular stability. Cannot be over-tightened, torque-limiting drivers. Self-tapping and can be self-drilling. Resistant to bending. 6. Disadvantages of locked plates, LCPs. Expensive. Challenging to use for achieving reduction due to critical steps in reduction, plate positioning, and screw insertion. Can lead to non-union with improper use, stiff plate, stiff screws, inadequate interfragmentary strain. Lack of tactile feedback during screw insertion. Catastrophic failure. 7. Indications for locked plates. Osteoporotic fractures. Comminuted fractures.